Welcome to the AI Research Roundup. I'm Alex. Today we're looking at a paper trending on X, published on November 11th, 2025, about 5 days ago. This paper unveils a hierarchical multi-agent system that reaches gold medalist or better performance across Olympiad benchmarks, for example scoring 36 over 42 on IMO 2025, a perfect 100 on IMC 2025, and 264 over 320 on CPHO 2025, beating the human gold record of 199. The paper is titled SciAgent, a unified multi-agent system for generalistic scientific reasoning. And as we'll see later, the cross-domain reasoning and adaptability are striking. Alright, the introduction set the stage with headline scores. Figure 1 compares striped blue bars for SciAgent against the highest, average, and lowest gold medalists across 5 contests. The chart shows SciAgent consistently above the average gold level, with a perfect 100% on IMC 25 and a strong 92% on IPHO 24. CPHO 25 stands out because the agent reaches about 83%, which exceeds the recorded highest gold score shown here. So the previous figure highlighted results, and Figure 2 explains the architecture. Figure 2 shows a coordinator agent that interprets each problem and routes it to domain worker systems, which then manage tailored reasoning plans. The left panels depict math, physics, chemistry, and general exam workers, each with multiple sub-agents like generator, reviewer, image analyze, and smiles verify that collaborate through critique revision loops. The right panel summarizes the design principles: hierarchical meta-reasoning, modularity with extensibility, and adaptive assembly. Okay, the previous figure laid out the overall system, and Figure 3 zooms into the math Olympiad worker. Figure 3 shows a structured reasoning review loop that favors uninterrupted symbolic deduction. The generate agent proposes a full solution, which the improve agent refines so the argument tightens and gaps close. The review agent then validates the proof and either issues an error report that routes feedback back to generation, or accepts once the number of passes reaches at least n. So the previous figure detailed the math worker loop, and Table 1 reports concrete scores on IMO 2025. The table lists problems 1 through 6 and the sum, with reference rows for total possible, highest gold, average gold, and lowest gold. SciAgent scores 7 on the first 5 problems and 1 on problem 6, which yields a total of 36. The average gold medalist totals about 36, while the maximum possible is 42, so the result sits firmly at gold level despite the dip on problem 6. Well, the previous table covered IMO performance. Table 2 reports IMC 2025, showing per problem scores across 10 tasks and the total. SciAgent posts 10 on every problem, so the sum is a perfect 100, which matches the highest grand first prize, while exceeding the average of about 89 and the lowest threshold of 83. The uniform row of 10s signals strong robustness across diverse topics like algebra, number theory, and combinatorics. Well, the previous table covered IMC 2025. Table 3 presents IPHO 2025 theory scores by parts and totals, and it shows a solid overall. The highlighted bottom row reports a theory part total of 25, which sits below gold medalists, highest at 29 and above the average at 23, and the lowest at 20. The middle block details uneven strengths. Theory 1 totals 9.6, Theory 2 totals 6.9, and Theory 3 reaches 8.5 because parts A to C contribute differently. So the previous table broke down IPHO theory, and Table 5 reports CPHO 2025 scores across 7 problems. The SciAgent row totals 264, with strong marks on problems 1 and 5 at 45 each, and moderate dips on 4 at 25 and 6 at 3.3. Gold medalist highest sums to 199, so the system clears that bar by a wide margin. The theory part maximum is 320, which sets the headroom for further gains. Wrapping up, 2 takeaways stand out. The hierarchical multi-agent design, with a coordinator plus specialized workers, adapts reasoning pipelines on the fly, and the system reaches gold level across math and physics contests while handling chemistry and mixed exams. The broader implication is practical cross-domain assistance for real research workflows. That is it for this episode of the AI Research Roundup. I am Alex. Thanks for listening.